Good. It's nice that we recorded.
Hello, everyone. I see already some people coming in. Hello, hello. See the number of participants still going up. Good morning, good afternoon, depending on where you are in the world.
Hi, Chet.
Hi, everyone.
Hi, Aris. Good afternoon, everyone. Welcome.
It's coming to a standstill. The number of participants. Let's allow for 1 or 2 minutes more.
Hi, Ilona.
I start. We don't have any elevator music going on, so you can imagine it on your heads, like some really cheesy elevator music.
And lobby music.
Nothing is going up apart for the number of participants still getting into the session. Okay, few more seconds.
Yeah, let's give a minute, I think, and then it should be everyone.
Still a couple more people just joined. And I think we should start now. Okay, so welcome everyone. Thank you very much for being here. It's a great pleasure to see that so many people decided to spend or invest a bit of their time listening to our product presentation today. My name is Hugo Carvalho. Most of you in Europe probably already know me. I'm part of the great team we have here in Europe. Today I'll be inviting, or we have invited Eduard Walker from South Africa to be with us. He is the head of our innovation projects for the Poynting Antennas group. And I think that he's the right person to tell you all about the ins and outs and the finest details about the product.
Thank you, Hugo.
Thank you very much, Eduard. So let's get on with it. Without further ado, I'd like to start from the very beginning. The reason for doing so is that a lot of you attending our webinar today are already familiar with Poynting. and our past. However, because the WaveHunter is such a breakthrough, a lot of new people just found out about our products and about our company these past few days or these past few months since we've been kind of putting information about the WaveHunter out there. So it's important to get starting from the beginning. Poynting started as a consultancy company in 1996. It then evolved to an antenna manufacturer later on 2001. In the beginning, defense and military were manufactured alongside commercial antennas and all sold under the same brand, Poynting Antennas. Having our roots on the military and defense environment really shaped who we are and what we do. In 2008, the company went public, and after a number of years, the commercial division, Poynting Antennas as you know it today, became a private entity, and it was bought back by one of its founder and still our owner, Dr. Andre Fourie. Since its inception, Poynting Antennas has a great focus on the electrical design of each of its antennas. Contrary to a number of other manufacturers, the radiation pattern of our antennas takes precedence over their gain, and this focus has led us to always challenge the status quo on the antenna industry. This led to over 50 patents on antenna and antenna design techniques that we currently hold. Headquartered in South Africa, the group has now a global footprint with branch offices in Europe and in the US. It has manufacturing facilities in China and in South Africa, and in both locations, we also have warehouses to help support the partners which are in the regions around it. Today, the team consists of almost 100 people with a single focus: to provide the market with antenna solutions which are highly reliable and which will deliver the most stable and consistent wireless connection. By now, you all get what we're all about. We're about consistent wireless connectivity. We're about getting people connected and businesses connected. But what makes us different? There are a number of important aspects on an antenna. Gain is important, and so is VSWR, for example. But there's nothing more important in an antenna than its radiation pattern. How predictable is the performance of the antenna? How stable is the connection that the user is going to experience? Everyone will talk to you about gain, how high the gain on their antennas is, not us. Quality over quantity, especially on the maritime environment where we all come from, or at least most of our audience today comes from. The vessels are constantly moving, and the antennas need to have exactly the same performance 360 degrees around it, being truly omnidirectional. Moreover, out at sea, the vessels will go through pitch and roll movement, and the vertical aperture of the antenna needs to be controlled to keep the masts onshore within their reach. We develop, we create, we design, and we manufacture our antennas, starting from our R&D department, which Eduard is representing here today. We hold over 50 patents, as I said, on antennas and on antenna design, and some other patents are still pending. Everything which we show on our datasheet is truly measured. What you see is what you get. That's our mentality. The carefully selected build materials inside and outside makes Poynting antennas to be very sturdy ones. Some of our antennas are IP68, foam filled, anti-vandalism design, you name it. Our antennas are ready for any environment and to last for several years. On top of that, our DNA is to make wideband antennas, electrically optimized to provide better gain throughout each of its working frequencies. Catering for all these frequencies will make it that your antenna will be picking up and working regardless of where you are in the world on any 4G and 5G connectivity infrastructure. Finally, we design our antennas so there's almost zero margin for error when manufacturing them, when transporting them, when deploying them, and then when using them for extended periods of time. This comes from thorough design processes and serious quality controls on all steps involved, from the design of the product to the last quality control on the manufacturing facilities. This is what makes Poynting antennas flawless. And Poynting isn't new to this world of maritime antennas. We're here today to talk about our most recent release, the WaveHunter, of course. But it's important to share a bit about our history and how we got here, especially on the maritime market. Poynting designed its first maritime antenna back in 2016, around 6 years ago. It was the 291 V1. It was initially inspired on our Omni 69, a very successful inland omnidirectional antenna. Its design, mechanicals, and accessories were redesigned to match the maritime environment when we decided to create the 291. Our journey in the maritime world has been quite a successful one. In the past 3 years, we've sold over 14,000 maritime antennas worldwide. Interestingly enough, we've had fewer than 10 quality claims, and none of them comes from electrical or mechanical reasons after the deployment. They were mainly due to appearance failures, either on the antenna or on the box itself. It is this track record of success that gives us the confidence to keep on evolving and creating new antennas for this niche and very particular market. Let me show you very briefly the antenna models which brought us here. As we've seen, the 291 was our first maritime antenna. And for the ones who like vintage stuff, you can still get the 291 today. Not the original one though. The current one is better electrically and mechanically, but it still looks the same on the outside. The mechanical design on the outside hasn't changed, not for the 291, not for a number of our other antennas. And this is for the 291, the 403, the 404, the 402, and the 414. The first models of these I just said, so the are size of antennas, 291, 403, 404 are size of antennas. This means that you only have an antenna inside of an antenna of the antenna enclosure. Now, as cellular technology evolved and we moved from lower category LTE routers into higher categories like Cat 12 or Cat 20 routers, and even now 5G routers, all these require more antennas. Due to installation constraint, this led to a bigger uptake by the market for more MIMO antennas. MIMO antennas, as I said, have multiple antenna elements within a single antenna housing. And this is particularly important for vessels where the real estate, the space that you have to mount the antenna becomes quite limited. That's why we have the 402 and the 414, respectively, a 2x2 and a 4x4 MIMO. Some of the things that all these antennas have in common, apart from its looks, its mechanicals, the quality of the build materials, the accessories, and a number of other things, is that all of them are pointing antennas. And being a pointing antenna means that they are true electrical design masterpieces. Now, the aforementioned need for higher MIMO configuration made it so that our engineers had to redesign the mechanicals and looks of our antennas. The main reason for this was primarily that the market wanted the performance of 4 493s, and each 493 is 65 centimeters tall, on a single enclosure. So they wanted a wideband, a high gain, electrical balanced antenna, but within a single enclosure. This would lead to a very tall antenna, and we had to create something new. So this year as well, we introduced the Narwhal series, a series of taller antennas which have an even stronger mechanical design that come in different MIMO configuration. We have a 2x2 and a couple of 4x4 antennas. I would like to make a specific and special reference to the 904, which combines 2 higher gain antennas and 2 lower gain antennas. And the reason for this, you might have imagined radiation patterns. We want to have the balance between reach and vertical aperture to make sure you can get as far as you can while the connection is as smooth as it can. These are our latest omnidirectional maritime antennas. The 291s, the 400 series, they have been successfully servicing all sorts of different vessels across the globe, from ferry boats in the fjords of Norway, all the way down to sailing boats in Cape Town, from container vessels in Singapore, all the way across the globe to super yachts in Miami. As you can imagine, Poynting in the maritime world, they have had a long and cheesy love story for quite a number of years already. Just imagine all those sunsets together in the middle of the ocean. Beautiful, isn't it? The WaveHunter is something else, and we're just about to get on about it. So let's go, and without further ado, ladies and gentlemen, it's my personal pleasure to introduce you to the WaveHunter. The WaveHunter is meant for the ones who are willing to challenge the status quo, for the ones who want to do things, achieve things, conquer things which have never been seen before. The WaveHunter is meant for businesses to have better and more reliable data on their critical systems. It is meant to get your loved ones closer to you, faster, and in a more real way than ever before. The WaveHunter is meant for businesses and for people to go beyond the connected life. But what is the WaveHunter? What is it? That's the question. The WaveHunter is a state-of-the-art sorry, I just jumped a slide. The WaveHunter is a state-of-the-art, multi-directional, multi-polarization maritime cellular antenna dome. This is a quite technical and short way of putting it. The long version would be, it is the highest performing 5G antenna dome ever designed in the industry, meant to be installed on vessels where you can house your 5G and 4G routers inside. This design will allow data connections to be faster, smoother, and furthest from shore than ever before. We created this antenna out of our experience of the current lineup, the evolution on cellular connectivity, and the feedback we got from the market. We wanted to look at the best possible combinations without constraints in size or parameters when designing it. So we gave freedom to our engineers. We ended up with an antenna that offers great flexibility for the end client to decide which router, manufacturer, and model he wants to work with. An antenna that can house up to 6 5G routers inside, leading to a max throughput that could well go up to 6 gigabits per second, if we are, of course, to take into account the latest 5G test results coming from the market. Depending on the infrastructure, an antenna that can keep us connected to up to 100 kilometers away from shore. An antenna solution which will maximize each of its 12 antennas which live inside of the WaveHunter, primarily to the housing routers inside of the WaveHunter, and then the cabling being very short, the coaxial cables. A ultra-wideband antenna. As I said, and that's also on our DNA, it's a ultra-wideband antenna that covers frequencies all the way from 617 to 4200 megahertz, all the relevant 3G, 4G, 5G frequencies that you can find on a cellular network. An antenna with 4 polarizations, 360 degrees around it. Horizontal, vertical, -45 and +45 polarizations. Probably this is still Chinese for you. Hopefully, once Eduard has explained you a bit more about the antenna, you'll make a better sense of why this is important. A multi-directional antenna that then ends up being truly omnidirectional, and where the user can select which antennas and which sectors he wants to use and to connect with these routers, the routers that he's going to place inside. An antenna which also has 4 dual band Wi-Fi and 2 GPS antennas inside, and also very important, an antenna which looks and which installation processes and mechanicals match VSAT existing antennas, so the know-how is already in the maritime market. Finally, there's always some fear about adopting new technology solutions. No one wants to be the first to adopt it. What if it's go wrong? Why if the product is not mature enough? The first good news is that the building blocks for our WaveHunter are the X-Pol2 5Gs. Tens of thousands of X-Pol2 5Gs have been sold throughout the last 3 to 4 years, with clients being very, very happy and always coming back for more. Secondly, as we speak, there are already a number of WaveHunters being installed in Southern Europe and also in the US. So I'm sorry to disappoint you, you won't be the first one to test it. Now that we've shared a bit on a high level what the WaveHunter is and what it is all about, it's time to delve into the further details. As I said, Eduard will guide us through that. Eduard, you can take the screen from here.
Thank you, Hugo. Let me just get the screen up, and then thanks for sharing. It's really an amazing story, and it's really beautiful. And you're wonderful with talking. I hope I can live up to the same standards. Okay. And, while I'm busy finding the share button here. Just give me a second.
There you go. We're seeing the wrong screen.
There we go. Is that the right one?
Yes, sir, it is.
Yes. Yeah, so it's time to delve into some further details. I believe this is going to be interesting. But let me just move to the correct one. From mechanical, skip to stylish on the outside. On the outside, this is what people are going to see. A dome, which looks like very similar to the most VSAT or TVR domes, but a specific curvature to make sure that it's strong and that it lasts in the environment. You already see a lot of domes on decks and bridges and on many different vessels. The WaveHunter has got two parts and a third optional one. On the top is the radar, where the antennas are housed, and at the bottom, we have an enclosure specifically designed for the LTE 4G, 5G routers, which makes this a fully outdoor 4G, 5G CPE unit. Finally, there's an optional pedestal for people that want to buy the full solution, but most such situations, the system integrator will use its own means and ways to install the WaveHunter onto a vessel. Let's start with the 5G compartment. As we all know, 5G is the words, and everybody wants to have 5G. Yes, that's true. But in Poynting, most things are not driven from a marketing perspective, but from an engineering perspective. So the reason for having this enclosure is so that people can use their own 5G router to incorporate into the device. You've got the best routers around there, and that's really what makes this a truly integrated solution. So the other thing with 5G routers is that they get hot and they get quite warm. So to mitigate this, we had to create some sort of heat dissipation. And this was done by designing the enclosure like a big heat sink made out of aluminium, which is a good thermal conductive material. And whenever possible, these routers should be installed into this enclosure, specifically designed as an equipment bay, and the routers need to touch this heat sink so it can conduct the heat to the outside. But we can assist with some discussions around that. Next slide would be the antenna lifting compartment. So what you have is in this enclosure, you have this compartment that can lift up with gas struts, similar to how a car's hood or the bonnet or the trunk opens up. So you've loosened the screws on the side, and the whole antenna dome part lifts, and then you have access to power units, or you have access to the routers so that you can work on it. And this can be done by a single person. So it's very easy to open and close. And once it's closed, it's secured and it's strong, and it's all functioning as one unit. In simple terms, opening the WaveHunter would be like opening your trunk, and you would expect it to stay open like that. And then we have different mounting options. So you can mount it with a pedestal. And this pedestal is an accessory. It's not necessary to purchase it. It's just for people that want to have a pedestal. But the mounting holes that you see, the 4 big mounting holes, those are according to industry standards. So many other antenna dome manufacturers, VSAT manufacturers use that same hole pattern. So the idea is that we would like to adjust to the market and to the current know-how of installing these types of domes, and not the other way around. The environmental specifications and the approvals, and finally, this dome itself, without any routers and the electronics inside, just the enclosure as you see it weighs 45 kilograms. It is 75 centimeters by 65 centimeters in size, and it complies with all the necessary salt spray, IP ratings, impact ratings, and all the criteria for surviving and living in the relevant environments. Its operating temperature is also very wide. That means that any kind of electronics that you mount inside will be cooled enough so that it can survive even on the equator environments where it's very hot. There's also a thermal insulation between the top and the bottom, so solar radiation onto the dome won't transfer to the inside where the electronics are housed. So that just also assists by keeping the electronics cool. Finally, the idea is, of course, that Ethernet cables and power cables needs to go into it so that you can have an Ethernet cable to go to the vessel's data center or to the bridge where the internet can be distributed further on. Some of the electrical specifications, yes. So the electricals is really the important thing, and that's what we're really proud about. Inside, you can see the X-pole antennas that we currently sell many of. That's a very reliable, very good performing antenna, and you know, as Hugo said earlier, this is what makes it really a multi-directional, multi-polarized omni antenna. So you can see that we have 12 directional antennas. Each one of them is a 2x2 MIMO. The bottom ones are vertically polarized, and then the top ones are cross polarized, or plus 45, minus 45. Having MIMO in the sense of polarization is really giving the big benefit towards the speed and the reliability of the connection. So the electrical performance that you get out of the different polarizations is quite a significant factor. And then now you will see, you know, all these antennas. This is just an illustration of the antennas that are going into multiple directions. You know, having 6 antennas at the top and 6 at the bottom gives you a spacing of 30 degrees, but the aperture of the radiation pattern of these antennas is close to 90 degrees. So there's a MIMO benefit that you get by combining the MIMO combining effect from the routers, and that's all standard in the routers. And having 90 degrees every 30 degrees gives you a full omnidirectional capability. So that doesn't matter in which direction the vessel is showing towards the shore, there will always be multiple antennas showing towards the shore with multiple polarizations, each covering a 60-degree sector. So that offers quite an advantage above single polarized antennas. It's also, we've also have I just want to see, what am I doing? Okay. So the cable loss is also a very big benefit. So having all the radios close to the antennas and using a solid, rigid copper coax cables, that eliminates a lot of cable loss. So having the routers close to the antennas has a very big contribution to good signal strength towards the towards the modems. So if you have long cables, there's some losses, but with this configuration, it's all integrated and it really contributes to good signal strength. Yeah, on these graphs, you can see that the VSWR, which is the voltage standing wave ratio, is basically how efficient the antenna radiates, is below 2 to 1. So, and that's across 90% of the band. This is what's expected from commercial antenna elements like these. On the gain side, we can see that there's a very flat gain response over the low frequencies, and the low frequencies are the important ones, because that's mainly used for remote and further off locations. The lower frequencies propagates much further than the high frequencies. And in near-shore communications, you'll see that it's mostly low frequencies that you'll connect to when you go far away offshore. And you'll see that the gain is quite good over there. When we go to the radiation patterns, that's, as what Hugo said, is that these patterns are quite important to us, and you'll see that in an angle of around about 90 degrees, you'll see that's the size that the antenna shines towards the cell phone tower. This will mean that the WaveHunter has 2 levels, each of them covering 360 degrees with superior gain. It also means that each pair of 2 consecutive antennas, one on the top and one on the bottom level, will cover the full 360 degrees. The vertical aperture is also important. That's the up and down beam width. This is more than 50 degrees. And that's important because the vessel has got pitch and roll. And as the waves pitch and rolls the antenna, there's enough aperture that is it's showing towards the cell phone tower. the challenge with omnis is that the higher the gain is, the smaller the elevation beamwidth is. But by using these X-Pol 2 radiators, you get a very big aperture. So it means that you will have a very reliable connection. Then we decided to take the WaveHunter for some sea trials, and we ended up going to Cape Town for a couple of days. The test setup was very simple. The WaveHunter has 12 antennas, 12 2x2 MIMO antennas. We combined them in pairs so that we can get 6 pairs of 4x4 antennas. Each of these setups we connected to a 5G router, 5G of course. We equipped the WaveHunter with 6 5G radios, making each radio responsible for a 60-degree sector. Inside the WaveHunter, we also had a server that was downloading and uploading files of 10 megabytes to 50 megabytes, and these files were sent to our data center in our office through the 5G network. The 5G network in South Africa, which is not necessarily as good as the 5G networks across other parts of the world. The server inside also polled each individual modem so that we can have the data details from each modem, the signal strength, the position of the base station, the height of the base station, the distance of the trip. So on our first trip to Cape Town, we did a route, and that's the route that you see there on the left. We went out quite far. Once we came back to the offices and analyzed the data, we realized that it would be nice to do a second and a third trip. We also then took another setup with us, which was another 4x4 5G radio connected to traditional omnis. And this was, the reason for this was so that we can have a relative test. It's always nice to say, oh, something is fast, but you don't know how fast it is compared to what. So here we could do a comparison between omnidirectional antennas and the WaveHunter. So we can see how many times the WaveHunter is better than traditional antennas. The same speed tests were done at the same data points, and you'll see that the second trip was the middle one, and then the third trip was the one on the right of your screen. Here you have a photo of the two setups. The WaveHunter is in the center of the vessel, and then on the rails we mounted two Omni 493s and two Omni 403s. The idea was to have a good balance between high and low gain. High gain so when we're far away, and low gain so we can compromise for the pitch and the roll. The WaveHunter couldn't be mounted any higher because that vessel wasn't that high and that big. But you know, it will only perform better the higher that you install it. So here is some interesting highlights. The maximum throughput that we got over various distances. So this 170 megabits was only on one of the modems, and it's not an aggregated speed. In the next slide, I'll show you the aggregated speeds. We went all the way to 70 kilometers offshore, and we still got 45 meg per second. So this graph is a lot more interesting. Here we can see the speed of the 4x4 omnis compared to the WaveHunter. So you'll see that the amount of times that it's better, it's almost in some cases more than 3 times faster than a omnidirectional setup with just omnis. So we got a 500 megabits per second speed when we close to shore, about 10 kilometers, and versus the 173. And then when we got all the way to 70 k's offshore, you can see that we still got 129 megabits per second versus 45. So that's the reason for the relative test, because 129 doesn't sound maybe that good, but if you compare it to what you would have gotten with a different setup, you can see that it is significant. It's more than double the speed that you got. So that's quite a
I
successful.
don't know if I can step in, Edward. These results we're seeing is the comparison of us of two are both the lines come from the WaveHunter, right? So basically the bottom line is from the best radio on the WaveHunter at that particular location, and the top
Okay.
line is the aggregate throughput from all the radios on the WaveHunter on that particular location.
Yes, that's an advantage as well with having multiple antennas going into multiple directions. It enables one to have, the routers will pick it will pick the connection that's got the highest speed with the highest signal strength, depending on the direction that it shows. The cell phone network sometimes hands you over to a tower that's further away, but it's not as occupied. It doesn't have so many clients. So that's just a standard optimization inside cell phone networks. And that's not always ideal for the end user. So having multiple antennas onto multiple modems enables you to always get the best out of what the cell phone network can provide. So here you can see that we were 70 Ks from the cell phone tower. You can see the signal, we were in the 900 megahertz frequency. That's, as Hugo mentioned, that always, the lower frequencies propagates a bit better and further away. So that's good to focus on those. And you can see that the speed that we got was about 40 meg in that specific point. But there were multiple, tests done every 2 minutes. The next slide is quite detailed. And I'm not going to spend lots of time on it, but basically what it shows is that we just highlighted a few data points where you can see the WaveHunter compared to the Omnis. And this is just one of the WaveHunter modems, and it's mostly double the speed than the Omnis at the same position. And it all translates to, the signal strength. It's directly relevant to the speed. This is a better explanation where we can show the aggregated of the WaveHunter versus the aggregated speed of the Omnis, and upload and download. The top graph is the download and the bottom graph is the upload. So, these tests were done in South Africa, and we expect that it's a lot faster in areas where the 5G networks are more evolved. I'm sure when you go to the Emirates or to the Mediterranean or to the US, you'll see gigabit speeds because the signal strength will go higher, but the capacity on the base stations is just not as good in South Africa as in other countries. So there, when you see some data points when we're far away and when we're close to the shore, it's similar, but in some places, because the WaveHunter connects to more than one tower, you get quite a good speed. Don't get us wrong. I mean, these Omnis are really good antennas, but however, it's really hard to compete with the WaveHunter on a technical level.
Eduard, can you come back a couple of slides? I know you're trying to fight the clock, and I'm probably delaying you here, but I see that people aren't leaving. So the one before that one. So people aren't leaving, so probably they're interested on it. I will send you the PDF, the one after that, the first one with the table. There you go, that one. So you'll get the table after, and you can draw your own conclusions here. There are a couple of points I would like to, even though Eduard probably wants to skip them because of time. I want to point them out. And the first point I want to point out is point number 36. So if we look at point number 36, you see the distance on our columns here are distance, frequency, RSRQ, RS, and all these radio details, and the throughput. As Eduard said, we're comparing the throughput of a single radio on the WaveHunter to the throughput on the single radio with the Omnis. You see that point 36, we have exactly the same, we're connecting to the same tower, same frequency, and there's only a difference of 3 dB. And the reason I'm bringing this up in terms of signal, there's 3 dB more or less of signal difference, and of course the power and the quality is also different. But you see the throughputs, they are massively different. And the reason is the 4 polarizations we were talking about. They are the same, the 2 antenna or the 2 setups are exactly on the same vessel connecting to the same mast on shore, but because we have 4 polarizations on one and we only have a single polarization, the vertical polarization on the other, and then of course the gain and the shorter cable runs and whatnot all add up to this fact, you see that the overall throughput, when you're comparing head to head, exactly the same position, same mast, is better with this new solution we came up with. And then if you look at the other values on this table, you're going to see that, for example, let's go, where is it?
Yeah, Hugo, I can add that it's not, if you look at the RSSI, there's 6 dB more signal strength.
Yeah.
And that it's every 3 dB is double the energy. So 6 dB doesn't sound lots, but it's actually 4 times the amount of energy that it receives. And as Hugo said, the multiple polarizations has got a very big impact, because as MIMO works, you need distinctive paths that are uncorrelated. So in an urban environment like where there's buildings, you can get those from scattering, from reflections. But there's nothing to reflect if you're in the middle of the ocean or 70 kilometers offshore. The only thing that you can do to get distinctive paths is to have more than one polarization. So just to add what Hugo mentioned about the polarizations.
Absolutely. And then one other point I would like to to highlight is point number 129. You see that the Omni setup connected to, and this goes to what Eduard was saying, the Omni setup connected to a mast which was 12 kilometers away from the vessel, while the best performing and radio on the WaveHunter connected to a mast which was 42 kilometers away from the vessel. So, and the throughput was doubled what we got from the antennas, the radio, because on the WaveHunter there was also a radio connecting to that same mast, and the throughput was similar, was around 20 megabits as well. But the best one was not the closest one, was the furthest one from one of the furthest ones. So this is also an highlight of what kind of performance you can expect with a WaveHunter. It's not just connecting to the closest mast. No, you will have the intelligence and the ability to connect to masts that a typical Omni setup, even though it's done with the best Omnis in the market, which are ours, it's not capable. It's not physically possible to get this kind of performance.
Yeah.
Sorry, Edward. I'll leave it to you.
No, that's good. Thanks, Hugo. I think what it means is that because you have directional antennas in multiple directions, it enables the WaveHunter to connect to the tower that's got the most capacity. So the cell phone network usually moves devices around to less congested towers. But where the Omni couldn't see that far, it was only 11 Ks, the directional higher gain antenna could see further, almost 4 times the distance. So that's a benefit, to have that versatility. Okay, thanks, Hugo. So let me carry on. Yeah, you can see the same. We've got this detail for every trip, but I think the message is clear. Here's another one. As Hugo mentioned, it's also double. So I think there's a lot of data, and there's a lot of proof that that it works very nice. And I think, I need to move to that one. So let me carry on and let me see, where were we? This is the one with the graphs, the comparison to the graphs. Okay, I think that brings me to the end of what I have to say. Hugo, thank you. Over to you again.
Thank you very much, Edward. I'll take it from there. Let me see if I can get my screen up there again. Okay, so possibly everyone is seeing my screen again, right? Can you see my screen, Edward?
Yes.
Okay, wonderful.
Thank you.
So yeah, a lot of insightful information. And I saw a couple of questions already popping up. We'll try to address them end of the session. And we will get to them, hopefully, if not by the end of the session, later on. You may now be wondering, after all this information, when do you choose the WaveHunter over, you saw a number of other antennas and the number of other options which are out there in the market. The WaveHunter was not designed for a particular type of vessel. It will find its purpose on all sorts of vessels, from passenger vessels to cruise liners to super yachts, and even on ferry boats. The WaveHunter is something else. The WaveHunter is meant for businesses and individuals who are not willing to settle for second best. It is meant for the ones who want to reach further, for the ones who want to be faster, for the ones who want to sail smoothly. And it might not be for everyone, but for the ones who go beyond what they thought was possible. The WaveHunter is for the challengers. And the question to you today is, are you one of them? And I will leave you with this question, and I will leave this question lingering while we go on to the questions and see if we can help make sense of some of the information we've shared today. So for someone who might need to leave already, we're almost done. If you can still stay around for the questions, thank you very much. If not, it was an honest pleasure to have you here today. Let me bring the first question, and probably I'll direct it to you, Edward. Let me just give me a second. Let me take the first one. So basically, there's a question on the Q&A of someone. This is the question every salesperson wants to hear, which is, how can I get one? Well, the WaveHunter, like any of our other pointing solutions, will be sold by our value-added distributors. Due to its more complex and very particular nature, you will only be able to get them from certified value-added distributors. Basically, these are from amongst our network of distributors, the ones that are closer to the maritime market and the ones who are closer or the ones who possess the right IT and networking know-how. Because the WaveHunter, being a number of sector antennas, it will require that the networking part is configured properly, and we want the market to receive the full potential of the unit. The installers and the system integrators will need to get certified as well, because they're also part of the path of the antenna to the market. And this if you want to get certified, reach out to us. You'll get our contacts, and our sales contacts are on our website as well. And I can already let you know that the next training session or the next certification training and exam will happen in May. So if you're interested, just drop us a line. We have a question then. Okay, this is a question we also get sometimes, and I'll send it to you, Edward. I'll let you answer this one. Who's going to provide the intelligence which determines which antennas are used? It's also hand in hand with what I just said. Which determines which antennas are used, and how does that look like? So where's the intelligence on the wave?
Okay.
That's the question.
So by using multiple 5G radios inside the equipment bay, these 5G radios are usually 4x4 MIMO, And most of the good quality or top radios that you get have got automatic load balancing and automatic, they've got functions and algorithms to do load balancing and to share data across, multiple routers, aggregate the speeds. So one connects one 4x4 5G router to two of the X-pole antennas, one on the top and one on the bottom. That gives you a nice 90-degree beam, because the two antennas are a little bit offset from each other, 30 degrees. It gives you the multiple polarizations, and the router itself it's part of the 5G standard, will then see from which antenna port it gets the most signal strength, and in such a way then aggregate the speeds over that 4x4 MIMO connection. Hugo, I'm not sure if you want to add something to that.
No, thank you. I'm happy with that answer. Thank you very much. There are a number of questions.
Let me just also quickly say is that, investing into a 5G router to get the best speeds is really key. If you want to use the best antenna, you need to use the best routers, the best modems as well. And that is a very potent combination.
And let's also address one of the questions we have here about a particular make and model of a router, which is if there's a minimum compatible router to the unit. And yes and no. So if you want to get the most out of it, that's probably you would go with 6 times 5G or 6 times 4G Cat 12 or Cat 20. And I reference these particular categories of the LTE technology because these are the ones who are MIMO 4x4. So you could create the 60 degrees sectors. But, and then I can discuss it with the person that got us the question. You can also do it with 4x4 routers, or you can also do it with 12 2x2 4G routers. It's really a matter of how do you want to play it. You can use different routers on top and then a load balancer below deck on the data center or on the bridge. So there's another question. It's a 50 kilograms dome. Do I need to lift it up every time I need to touch the router? No, you don't. That's the car trunk mechanism that Eduard explained. The gas lifters, you'll just unscrew every single screw on the bottom of the enclosure. They don't fall down. They are designed to be unscrewed and stay on. I cannot recall the name of these kind of screws.
Captive screws, so they won't fall out.
And then the WaveHunter, just the antenna part lifts, stays up. You can perform whatever you need on the router, and then you can put it down. So you don't, yeah. And even if you wanted to take the top part to the side, that doesn't weigh 50 kilos. That's the lighter part of the antenna. The heavier is the aluminum heat sink that we have.
Yeah, so you can also take the top part off. It's we show it on the installation manual if you want to take it off. And there's a lot of space inside the equipment bay. It's almost 4U is inside there, so you can easily fit a 2U rack mount routers inside there.
What else have we got here? Okay, interesting question, and quite technical. We have debated about it. How will it coexist in terms of interference with existing onboard systems like VSAT, domes, or radars already installed on top of the vessel? So I'll take this one because it's something that I have addressed in the past already with a few of our partners. So the installation of the antenna that will be available goes up into this topic already. And then on top of that installation manual, we have a separate technical paper written by one of our senior RF engineers just addressing these and the very technical details about it. All in all, there's not a straightforward and simple answer to this question. Apart from the typical and annoying, it depends. It really depends on where can you mount the WaveHunter and where are the radars and the VSAT domes. As a rule of thumb, with VSAT domes, it's easier to handle them. It still needs to be case by case. It's easier to handle. But with radars, we have, as a rule of thumb and as a best practice, we are advising people to install the WaveHunter either 1.2 meters above it or below it, and at least 4.6 meters apart from it. But this is when it's possible. When it's not possible, then we need to refer to that technical paper, and we really need to do the math. Or there are a number of other tweaks that can be done on the WaveHunter side to protect the radios, but it's know-how that we're going to pass on during the certification program as well. So let me check.
Yeah, thanks, Hugo. So we're not too concerned about VSATs because that mainly radiates up into the sky. But radar has got quite some power. So, and you know, you don't really want to mount something close to the antenna because it's omnidirectional and you're going to block a part of the aperture. So let's say, for instance, there's a big mast between the shore and the antenna. That mast might, you know, it's just one of those things. It's like light. It's just going to stop it. So it's good to have it mounted a little bit further away. And then refraction and diffraction from the RF will happen over the mast, and you will have a 360 view again.
What else? Question also for larger vessels, would multiple units be required? It really depends. We know that there are going to be, it depends on the installation circumstances, and where can you install it. We know that there will be blocking elements, especially on larger vessels, and these blocking elements, if made by metal, they will cause reflections and will get that the dome part that's facing those. But it's like with any antenna, which is, if it's blocked by metal, it will not perform to its prime. So it might be needed to put a dome on the other side of, say, the chimneys of I'm thinking about the cruise liner on the other side, to make sure you have your 360 degrees coverage.
Hugo, I can also add that, you know, from a super yacht perspective, symmetry and looks is quite important. So we do also offer a empty dome, you know, so that if you want to mount one on the starboard side, you can, on the port side, you can also mount an empty one, which is also, obviously it's a little bit, it costs less, but then you can have two and it looks, you can have the symmetry and it still looks good. So that's also an important thing.
Absolutely.
Just to know that we have that product.
And I think we've gone through most of the questions. And there's questions about partnership, and we have a question about the latency of our tests. Did we collect this? I don't know. We need to double check.
Yes, we have the raw data.
Okay.
We have the raw data of the latency that in milliseconds. It's not in the tables. So we can, you know, if somebody's interested, we can extract it out of the raw data and add it a column to the speeds. Yes, the latency is important when it comes to IoT or mission critical control systems or remote control systems, and also to voice. So, but usually latency is also improved as the signal strength improves.
Okay, and then final question I want to address, we're just on the time, is using an internal antenna combiner an option if you only have 3 routers with MIMO? It's a matter of as doing the math, right? So we will there are losses that come with by using combiners and splitters, and so it's a matter of understanding if the advantages outweigh the disadvantages on that particular case.
If you have as long as you can, we can assist to recommend which antennas to connect to the router so that you can still get the most omnidirectional look, you know, the most omnidirectional performance. So yes, you can. It's not ideal. You will compromise the total aggregated speed, but we can help to recommend which ones to connect.
I did the exercise the other day for a partner of ours of using just four 5G routers. So it was a router that they have 4 5G radios inside, and I can still get because of the wide aperture that you showed on the radiation patterns. I can still have 360 degrees 100% of the time with a minimum gain of max gain minus 3 dB. So 5 dBi. Typically on the lower frequencies. I can still have a 360-degree coverage, but only with 2 polarizations. For the 4 polarizations, I get 90% of that 360 degrees is still 4 polarizations. The other 10% will only be 2, but it will still work. So there's a way of, even if we neglect and not connect a few of the antennas inside, namely 2 sectors, 4 antennas, it will still work and it will still be able to provide the 360 degrees coverage. It's not, of course, ideal, and we.
I see there's a question regarding a smaller unit. Yes, within the last quarter of this year, we plan to launch a smaller unit. So stay in touch. And the radome is made out of fiberglass and not PVC, so it's strong. I mean, I can stand on it, and nice and rigid.
Okay, I think we've addressed most of the questions. So if you have any further questions, please do feel free to reach out to us. You can find us on our contacts. We'll probably circulate on the emails following up this webinar. You can find us on LinkedIn, and you can always reach out to any of us or to any of the sales team through our sales emails. So thank you very much. It was a pleasure. I hope you learned something and that it was valuable, the time you spent with us today. And I would like to personally thank Eduard for accepting the invite to be with us today. It was a pleasure to have him. And we see you next time.
Thank you, Hugo. Have a good day.
Thank you.
I hope it was interesting.